Welcome everyone, this is a Legacy School Science lesson on Chemistry for Year 8 about patterns of reactivity. For this lesson, you will need your Science Checkpoint Book 3, pages 145 to 151. Sodium is so reactive that it has to be kept under a layer of oil. The reason for this is that it will readily react with water and oxygen in the air and produce flames. Sodium is a very soft metal and can be cut with a knife. If a small piece is cut and exposed to the air, its shiny surface quickly tranches as it reacts with the air. On pages 143, we saw that iron reacts with damp air and turns into rust. This reaction takes place much more slowly than the reaction between sodium and the air, and suggests that metals have different speeds at which they react with other chemicals. Reaction of metal with oxygen. Here are some descriptions of the reactions that take place when certain metals are heated with oxygen. Carbon develops a covering of black powder without glowing or bursting into flame. Iron glows and produces yellow sparks. A black powder is left behind. Sodium only needs a little heat to make it burst into yellow flame and burn quickly to leave a white powder behind. Gold is not changed after it has been heated and then left to cool. From these reactions, we can tell that when we have a metal reacting with oxygen, it produces a metal oxide. As we can see, sodium burns rapidly in the gas, and sodium oxide powder is left behind, which is the white powder. So when a metal reacts with oxygen, it produces a metal oxide. Metals plus oxygen gives a metal oxide. Reaction of metal with water. Here are some descriptions of the reactions that take place between water and metal. In the study of these reactions, the metal were first tested with cold water. If there was no reaction, the test was repeated with steam using the apparatus shown in figure 10.13. This is figure 10.13 showing the reaction using steam. As you can see, we have a wool soaked in water that's placed, and then we place that sample of metal that we have. We apply heat to the wool that's soaked in water, and it's going to produce hot steam. If the metal will react with the hot steam, hydrogen should be formed. This gas will transfer into a water container. On top of the water container, if you placed a test tube full of water, then the gas will enter the tube, replacing the water. Calcium sinks in cold water and bubbles of hydrogen form on its surface, slowly at first. The bubbles then increase in number quickly, and the water becomes cloudy as calcium hydroxide forms. The bubbles of gas can be collected by placing a test tube filled with water over the fizzing metal. The gas pushes the water out of the test tube. If the tube, now filled with gas, is quickly raised out of the water and a lighted splint held beneath its mouth, a popping sound is heard. The hydrogen in the tube combines with oxygen in the air, and this explosive reaction makes the popping sound. Copper sinks in cold water and does not react with it. It also does not react with steam. Sodium floats on the surface of the water, and fizzing sound is heard as bubbles of hydrogens are quickly produced around it. The production of the gas may push the metal across the water surface and against the side of the container, where the metal bursts into flame. A clear solution of sodium hydroxide forms. Iron sinks in water and no bubbles of hydrogen form. When the metal is heated in steam, hydrogen is produced slowly. Magnesium sinks in water. Bubbles of hydrogen are produced only very slowly, and a solution of magnesium hydroxide is formed. When the metal is heated in steam, the hydrogen is produced quickly. Potassium floats on water and bursts into flame immediately. Hydrogen bubbles are rapidly produced around the metal. A clear solution of potassium hydroxide forms. This is a picture showing the reaction of potassium with water. As you can see, the metal immediately starts to react with the water, forming potassium hydroxide. So when we have a metal plus water, the end result is a metal hydroxide plus hydrogen. Reaction of metals with acids. Sodium and potassium react violently with acids. Other metals react less violently. and their reactions with dilute hydrochloric acid can be studied using a test tube as shown in figure 10.5, or with the setup of apparatus shown in figure 10.6. A piece of metal is placed in a test tube or flask, then acid is poured in it, and the bubbles of hydrogen gas are observed. The reaction of metals can be compared by simply comparing the amount of hydrogen produced in the reaction between the acid and different metals. The general word equation for this reaction is metal plus hydrochloric acid gives metal chloride plus hydrogen. So as we have seen so far, the reactions differ according to the metal type. And as we have seen, sodium and potassium react very violently. They are the first to react either with oxygen or with water, and now with acids. If the acid was another acid, let's say sulfuric acid, then it will be a metal plus sulfuric acid. It will give metal sulfate plus hydrogen. So the acid doesn't always have to be hydrochloric acid. This is the reaction in figure 10.5 that shows the aluminium reacting with dilute hydrochloric acid. As you can see, when you place the aluminium and then you pour the acid into it, you start to see bubbles. These bubbles are the hydrogen bubbles. This is figure 10.6, and it shows also the investigation of metals with acids. As you can see, the metal is placed inside the flask. The metal is placed inside the flask, and then acid is poured into it. So when this metal starts reacting with the acid, the hydrogen bubbles are then collected through this tube and they go into the water. If a tube or a test tube that's full of water is placed on top, it will start to collect the gas, which is the hydrogen gas. As the hydrogen gas enters the tube full of water, it will push the water outside of the tube. The apparatus in figure 10.6 is designed to collect any hydrogen that is produced in the reaction. When the acid is poured in down the funnel, it should reach a level above the bottom of the funnel tube. The hydrogen escapes from the bubbles at the surface of the solution and pushes air out of the flask and down the delivery tube. A minute should be allowed for the gas to escape from the end of the delivery tube, and then a test tube full of water can be put over it to collect the hydrogen. As the gas collects in the upthrust test tube, it pushes water out at the bottom. When the tube is full of gas, it can be closed with a plunge or stopper and replaced with another tube to collect any more gas that is produced. Here are some descriptions of the reactions that take place between different metals and hydrochloric acid. The metals were first tested with dilute hydrochloric acid. If the reaction did not take place, they were tested with concentrated hydrochloric acid. So they tried it with a dilute acid at first. If the metal did not react, then a stronger acid, a concentrated acid, is used. Lead did not react with dilute hydrochloric acid, but when tested with concentrated acid, bubbles of hydrogen gas were produced slowly. Zinc reacted quite slowly with dilute hydrochloric acid to produce bubbles of hydrogen. Copper did not react with either dilute or concentrated hydrochloric acid. Magnesium reacted quickly with dilute hydrochloric acid to produce bubbles of hydrogen, which suggests that magnesium is more reactive than lead, for example, and more reactive than zinc and then copper, because it reacted with the dilute acid. They didn't even need to put it in a concentrated acid. So a metal plus hydrochloric acid will give metal chloride plus hydrogen. Displacement reactions. When metals react with acid, they displace hydrogen from the acid and form a salt solution. In a similar way, a more reactive metal can displace a less reactive metal from a salt solution of the metal. As we have seen in the previous reactions, for example, when the metal reacted with hydrogen, it displaced one of the hydrogen atom. It became metal hydroxide plus hydrogen, so a hydrogen atom was released. Same thing with the acid, and hydrogen atom was released. It was replaced with the metal. In the same way, a metal can be replaced with another metal. So a more reactive metal can displace a less reactive metal in a salt solution of the metal. When copper wire is suspended in a solution of silver sulfate, the copper dissolves into the solution to form copper sulfate, and silver metal comes out of the solution and settle on the wire. Figure 10.7. As you can see in the figure, when we have a solution of silver sulfate and we place a copper wire into it, then copper is more reactive than silver, so it will displace the silver. It will take over the silver's place, and we end up with a solution that's now copper sulfate rather than silver sulfate, and the silver forms a layer on top of the copper, or on top of the wire. If a nail is placed in copper sulfate solution, the iron dissolves to form a pale green iron sulfate solution, and the copper comes out of the solution and coats the nail. The reactivity series. In chapter 8, we saw how chemists sorted out the elements into order according to their atomic number and their properties to produce the periodic table. Chemists have also looked at the reactivity of metals and arranged them in order too. The metals are arranged in order of their reactivity, starting with the most reactive. The reactivity series is produced by studying the reactions of metal with oxygen, water, hydrochloric acid, and solutions of metal salts. Table 10.1 shows 11 metals in the reactivity series and summarizes their reaction with oxygen, water, and hydrochloric acid. This is table 10.1. As you can see, we have the metal starting from potassium and ending with gold. And then we have the reaction with oxygen, reaction with water, and reaction with acid. As you can see, as we go down the series, or as we are going less, or as we're moving downwards, the reactivity is decreasing. Starting with oxygen, and the first element we have is potassium. Potassium form oxides vigorously, then followed by sodium, less than potassium. Calcium is less than sodium, magnesium is less than aluminium, and so on. Same thing for water. As you can see, only potassium and sodium react with cold water, and then starting from calcium down until iron, it reacts only with steam, and then from tin downwards, there is no reaction. With the acids, also sodium and potassium react vigorously or give a violent reaction, and the rate of the reaction decreases as we move down the table until we reach iron, after which for tin it reacts very slowly, and then for copper, silver, and gold we have no reaction. This is the end of today's session. Hope to see you again soon.